Good morning. Uh, Today I will teach you how to draw the projections of a plane which is resting on VP on one of the sides. Till now we have learned how to draw the projection of a plane lamina which is resting on one of the sides on HP. In this class I am going to teach you how to draw the projections of a lamina which is resting on VP on one of the sides or edges. Okay, so in this, when the lamina is, he says that when the lamina is resting on VP on one of the sides or edges, you have to imagine the lamina to be completely resting on VP, okay, and perpendicular to HP. So in this position you have to draw the initial views of the lamina. That is, in the front view the lamina appears as a equilateral triangle. If you consider a equilateral triangular lamina, okay, you will see a equilateral triangular lamina like this in the front view. So this is the edge on which it is resting. It will be to your left, okay, and it will be perpendicular to HP. That edge must be perpendicular to HP. So here today you are going to learn how to draw the projections of a lamina resting on VP on one of its side or edge. Okay, so as I said, you have to imagine the lamina to be completely resting on VP like this. Okay, so vertical plane means it will be like this. So this will be the vertical plane. Okay, you can see you have to imagine the lamina to be completely resting on VP such that the edge on which it is resting on VP must be perpendicular to HP. If this is HP and this is VP. So in this position, in the front view, you will see the true shape of the lamina. So we draw the XY line. In the front view, you will see the true shape of the lamina like this. So if you name the corners as A, B and C, AC will be the edge on which it is resting on HP, on VP, sorry. So in the front view you will see the true shape of the lamina. In the top view, if you look from the top, you can see it appears as a line. Okay, it appears as a line only. So because it is resting on VP, the top view will be a line on XY line. So draw the projectors from A, B and C and on the up to XY line, and this will be the top view. Sorry, this is A dash, B dash and C dash. This is A, B and C in brackets. So this will be the initial position. Similarly, the initial position of a square lamina will be like this. The front view will be like this. In the top view, you will see it as a line on the XY line. I have given in the notes, you can refer to my notes about this. And if it is a pentagonal lamina, in the front view you will see the pentagon, regular pentagon. The edge on which it is resting must be perpendicular to HP. Okay, and in the front view you will see a regular pentagon. The top view will be a line on the XY line. Now the next position, in this case he will give you, I told you in any problem he will give you three positions of the lamina. So one is it is resting on its edge or corner, he will say. In this case it is resting on its edge. Next is he will say the VP condition, the surface of the lamina is inclined to VP at some angle, that is phi degrees, and the edge on which it is resting is inclined to HP at some angle, that is theta degrees. Okay, so this will be the type of problems which you will get. We'll take the example of a triangular lamina. We'll assume that the surface of the lamina is inclined to VP, okay, at say 45 degrees. So as you know, the inclination with VP will be seen only in the top view. So in the top view, what you see is the lamina is like this, the initial position. Okay, so you will be seeing only the line. Okay, and then if you rotate this lamina so that it becomes inclined to the vertical plane, so again you will see the line leaving the XY line and coming down by an angle equal to 45 degrees. So A and C will always be on the XY line in the top view because the lamina is resting on A and C, the edge A and C on VP. Okay, so draw a line inclined at 45 degrees. The length of this line must be equal to the length of A and B. So measure the length AB and mark off here. So this will be the new top view of the lamina which is inclined to VP. So this is the end B. Now to project the front view of this lamina, draw the projectors from A and C, vertical projectors, and from A dash, previous A dash, draw a horizontal projector. The point at which it cuts, that will be the new A dash, and from C draw a horizontal projector. So this will be the new C dash. Okay, now from B draw the projector, vertical projector, and from the previous B dash draw a horizontal projector to cut that. So all these are construction lines, they must be thin lines. So this will be the point B dash. Now join A dash, B dash and C dash with dark lines. So this will be the new front view of the lamina. The angle is 45 degrees, that is phi. Okay, so this is called as the VP condition. So as you can make out, when the lamina is resting on HP, after the initial position you have to fulfill the HP condition, but when the lamina is resting on VP, then you have to draw the initial position. Next you have to fulfill the VP condition. Okay, so next is the HP condition. In the HP condition, what he may give you, he may say that the edge on which it is resting on VP is inclined to HP at say 30 degrees. Okay, so that is theta, 30 degrees. So this is the edge on which it is resting on VP. So this edge is not perpendicular to HP, but in the problem he says it is inclined to HP at 30 degrees. So what you do, you draw in the front view, draw a line inclined at 30 degrees to XY line. So this is inclination with HP. So this is 30 degrees. On this line you take the edge A dash and C dash. Measure A dash and C dash from here. This will be C, let this be C and this be C dash, and this is A dash. Okay, now to complete the front view, what you have to do, this is A dash and C dash. So measure C dash and B dash. This will be equal to A dash and B dash. Okay, so measure with C dash and B dash as radius. with C as center, draw an arc. Then with A dash as center, cut that arc. You will get the point B dash. So join A dash, B dash and C dash. This will be the new front view of the lamina. You do it to scale using the instruments. Now you have to project the top view. So in the top view you can see that A and C are on the XY line. So draw projectors from A, you will get A. From C dash draw the projectors to cut the XY line, you will get the point C. Then from B draw the vertical projector, and from the previous top view of B draw a horizontal projector to cut this. This will be your new B. So join A, B and C. So this will complete the problem, and this is known as the HP condition. It is known as the HP condition. So similar problems you have solved when the lamina is resting on HP, but now it is resting on VP. So you have to start from the front view, the initial position. Front view will be a true shape of the lamina. Top view will be a line. Okay, next VP condition, and next is HP condition. This is the steps which you have to follow in all the problems. Okay, suppose if the lamina is a pentagonal lamina like this, pentagonal lamina resting on VP. So draw the pentagon, regular pentagon, making one of the edge perpendicular to HP. So draw a regular pentagon in this position. This will be the initial position. So name the corners as A, B, C, D and E. Then the front view, top view will be a line on XY line. This is the XY line. Top view will be a line on XY line. So B and D will be in the same line, and C will be here. So you have got 3 points on the XY line. So this is A, which is visible from the top. A is visible, sorry, this is A dash, B dash, C dash, D dash and E dash. A is visible, B is visible, C is visible, and here D is invisible, so it is in brackets. E is invisible, so it will be in brackets. So join all these points, you will get the top view of a lamina which is resting on pentagonal lamina which is resting on VP. So this will be the initial position. Next will be the HP condition. Okay, so HP condition, next will be the VP condition. In VP condition you have to rotate the top view so that it becomes inclined to VP. Okay, and next the third position will be the HP condition. So similarly for a square lamina, if it is a square lamina, so this will be the initial position. So this is A dash, B dash, C dash, D dash. Okay, draw the projectors from here up to XY line. This will be the top view. So this will be the front view, and this will be the top view. A, B, C in brackets, D in brackets. So if it is a hexagonal lamina, it will be like this. This is A dash, B dash, C dash, D dash, E dash and F dash. So the top view will be a line on XY line. B and E will be in the same line. Okay, so draw the projectors. This distance and this distance must be same. So you will get 3 points here. If you are viewing from the top, A dash, B dash, C dash are visible corners. So A, B and C are visible. Okay, then D, E, F are invisible. therefore they must be in brackets. So this will be the initial position. Next will be the VP condition, and then you have to solve for HP condition. So I have given in my notes. I think you can solve these problems. Problem number 11, 12, 13, 14, 15 and 16. Okay, so please try to understand and solve the problems. Okay. Next, in the next uh, video, I am going to teach you how to solve the problems when the lamina is resting on its corner on HP. Thank you.